And we have started. So, first of all, it is the fourth part of material of the lecture. So, some issues that I will tell you during this course. You will find familiar with because you have heard something like that during previous courses during the studying at the academy. So, and the first question is why is discipline necessary? So, first of all, it will help you to collect all the knowledge that you have in the structural direction together. So, it's just the generalization of knowledge in special disciplines, and it will collect all the structural disciplines that you have already considered. It's like strength of materials, it's like constructions of building structures, part one, two, three, etc. So it will give you to collect the general volume of knowledge using which you will be able to work as a real architect, not only like a designer. Also, it is completely 100% related to the profession because all the issues that I will consider during these lectures are connected with real life, with practice. Some questions you will find hard to understand. It will be difficult for you to understand why architect needs to know how to work in the circumstances where you have to design the building in seismic regions or proof to the landslides, but all these issues like landslides, seismic regions, or, for example, undermined territories. It's a part of our practice. Even in Odessa, we have a lot of difficult ground conditions, which significantly influences on the architectural on the architecture of the building. It's connected with the exterior of the building and also connected with the interior of the building. So all these issues are important for you as a future architects. And also, this discipline is necessary because it will give you a chance to work as an architect, as a real architect. Because sometimes we have the next situation. There are a lot of good designers, and they call themselves architects. And they can create a beautiful picture of the building, beautiful idea of the building, and client likes this idea, like this picture. And but after the idea, after the first concept design, the client wants to for this building, for this picture to be built, and he goes to the company like mine and he asks me to develop the project of the building which he sees on the picture and he likes. And we have a lot of situations when it is impossible for us to make the same building as we see on the picture, because sometimes such designers that call them architects makes a long span slab, for example 12 meters, with a thickness only 200 millimeters, and that is impossible to make in any kind of constructions. Right now we have a project which was developed by a famous Ukrainian designer. He called himself an architect. I don't know to tell you his name and surname, but nevertheless, he have created beautiful building. It's not from Ukraine. It's abroad. It's okay. It will be located abroad, and they have created beautiful building. But now we have next situation. He have prepared a beautiful drawing of thin structural elements. But when we have calculated, we explained them that it is impossible to make beams with the height like he wants, because in such situation the beams have to be much higher. Also, in addition to the big height of beams, we have additional height of the ceilings, which increased it by ventilation and other engineering nets. and that makes the thickness of the roof structure higher and higher. So in the situation that we have in that country, it is impossible for us to increase the height of the building because we have certain limits from the local government. So, if it is impossible to increase the height of the building, in that case, we have to reduce the height of the space. And when we are when we are designing a structure which is thicker, when we are adding additional engineering nets, it reduces the space inside, and it make these buildings not as beautiful as it was designed previously. And all this connected with the situation that designer doesn't know anything about the engineering nets, about heating, ventilation, and air conditioning. He can create a good picture, but he doesn't understand the real building, the problems of real building. So that is why it is important for you. It's related not only to the structural elements, but mostly it is related to the structural elements. Also, it is really necessary for you to be informed in a very deep way, to be informed, deeply informed with the issues which are connected with heating, ventilation, water supply, sewerage, etc. So, and without understanding of the real work of structural elements, it is impossible for you to understand how to design how to design real buildings. One of my main architects in my company, he is a well-known person with older than 60 years, and he knows structural elements in a very good way. He understands structural elements. He understands the thickness of columns, thickness of beams and slabs, and that makes him to be informed in structural elements like some structural engineers. And one of my colleagues, not from my company, from another company, he knows my main architects, and my main architect, and he asked me once that do you know that your architect has also not only architects education, or he also has an education of structural of civil engineer. I said, no, it's not true. Why? Where have you found it? Because he told me that when he was working with my main architect during the project in Crimea, it was before the war. He told he's so informed in structural elements. I thought he has also education of civil engineers, of structural engineers. So that is why it makes this my main architect a real architect, not just a creator of good pictures. So that is why for you, when you will work as the main architect, you have to be informed also in map engineering, also in structural elements, and including all this information, you have to create good picture which can be implemented in the way that you have described it on your picture. So all my discipline will consist of three main models. So first model will be devoted to the construction solution for residential, public, and industrial buildings. Second part will be devoted to the difficult ground condition. And third section will be, it's like one lecture, will be devoted to reconstruction, because the reconstruction is also very important part of architect's life. And right now, during the war, it is one of the most needed direction of the designer's work, because we have a lot of buildings and structure which are in very difficult conditions after the drone attacks, missile attacks, etc. So, and you as a future architect, if you are planning to work in Ukraine, you have to be informed about reconstruction in a very good way. So that is why today we will start our first section, first model, which will be devoted to the structural solutions, so for residential, public, and industrial buildings. Yeah, it's the best way to write it, it will be structural solution. So, do you have any question for me about the intro that I just completed? So, and first model will be started from the main terms that we will consider during our lecture, and some of these terms will sound familiar for you. So, structural type, structural system, and structural scheme. So first of all, when we're talking about the structural type, it's a system of vertical. It's like walls, columns, horizontal floors, roofs, beams, and arbitrary oriented elements which support the spatial stiffness and geometric stability of the building. So also we will consider these terms in the future. So the highest step of classification of structural type is connection of all load-bearing elements. Next steps and next types of classification that we will consider, it is will be like subtype of this structural type. So, and if we will consider this picture, the picture of the structural scheme of one of the buildings that I have designed in Odessa, it's multi-story building. So this part of the building you can see exterior walls, and here you can it's impossible for you to see those exterior walls. Why is that so? So this is a calculation model. It was for calculation of this building for one of the cases. And why do we see these walls here and we don't see these walls here and here? Because these walls are non-load bearing. Only load-bearing elements in this building are these columns and walls and slabs, and also foundation slab and piles. These walls are non-load-bearing walls. These walls are made from aerated concrete. It's called in Ukrainian gazobeton. Aerated autoclaved concrete (AAC), and these walls are not bearing the loads from the slab of the upper floor. So it loads only wind load from the outside, and it loads only, it bears only its own load, own weight, well, the load from the own weight. So the all load-bearing elements you can see above, because here there are non-load-bearing elements which are not included in the structural type of the building. And there are three main structural types. First of them called the mullion beam. And if you will compare this mullion beam structural type, which was used in Malta 3.6 thousand years before Christ, and contemporary residential complex Altair, which was erected in 2015, you will see a lot of common. Yeah, we can see that the materials are different. Yeah, here we can see the limestone, and here we can see load-bearing concrete, heavyweight concrete. But nevertheless, mullions elements, vertical elements, and beams are located in the same order. So that make it possible for us to call all these building mullion beam, because this structural type consists of vertical elements and horizontal elements. So it's mullion beam structural type. The next structural type, which we will also consider during our lectures, it's called vaulted arches. And sometimes we can find natural arches and vaults in the around us. Sometimes we can see same ideas in various structural solutions like aqueducts and some other solutions which are used to cover some religious or cultural buildings. So, mullion beam, vaulted arch, and the most modern, the most contemporary structural type, which is called suspended. So there are three main structural types, and all buildings with and structures that we can see around us belongs to one of these three structural types, and more than 90% belongs to the first mullion beam because it is the oldest structural type, and it is the easiest structural type to erect, and so that is why it is more widespread around the world compared to the other structural types. And if we will consider the history of development of structural type, we will know that the oldest one, the most widely used, was the mullion beam, the first one that we have considered. But nevertheless, vaulted arched and suspended structural type also become more and more widely used. But we have to compare the structural system from the point of view of their load-bearing behavior under the load. So, and to analyze these structural types, I prepared the table that you can see at this slide. So we have to analyze the horizontal or arbitrary oriented elements which bears vertical loads like slab and roof, and also vertical elements which bears vertical and horizontal loads. So when we are analyzing vaulted arched system, we have compressions all over these elements. So that gives the ability to make these structural elements as thin as it possible. So on previous side, there was an information about the dome with the diameter of more than 55 meters, and the thickness of the dome was only 7 centimeters. So imagine 55 meters the span of the dome, 55 meters, and the thickness of the dome only 7 centimeters. And if you will compare this, for example, with the mullion beam, so the height of the beam to cover such a big span will be like 5 meters. So the height of beam or not beam, maybe it will be truss. The height of truss element will be more than 5 meters. Just imagine 7 centimeters in vaulted arch structural scheme, because all the elements in vaulted arch structural type are compressed. And if you will compare it with the mullion beam element, we have significantly bigger height, like in 100 times higher thickness of this element, because it is under the uh, mixed compression situation where we have to deal with tension and also with compression. So when we're analyzing wall-attached elements, slabs and roofs of these elements are in the state of compression. When we're analyzing vertical elements for such structure, they are in a mixed situation because there is torsion and compression for these elements. When we're analyzing suspended scheme, we have tension in roofs and slabs of this building. But when we're talking about vertical elements, we have the off-center compression. It is the mix of compression and tension. And when we're analyzing mullion beam, the most widely used element, we have in the horizontal element mixture of tension and compression. The upper part is here in this span is compressed, the bottom part is under the tension, and the columns are in the state of the off-center compression. It is the mixture of compression and tension. So next step, it is devoted to the redistribution of the interior forces between horizontal and vertical load-bearing elements. So you have to understand. And further, we will consider only Malyan beam structural type, because it is most widely used, and it has certain simple classification. Because when we will try to analyze the classification of the suspended and vaulted arched structural types, the structural schemes from these types are in a very difficult typology, and we have to analyze various dissertations devoted to this situation, because the buildings with the vaulted arched or suspended schemes are unique. So that is why makes the use of this structural scheme makes like something exclusive, and all exclusive connections, and it is really hard to make a classification of the exclusive solutions. So that is why further we will analyze only Malyan beam structural type. And first of all, we have to analyze the redistribution of the internal forces between horizontal and vertical elements. And we understand that horizontal elements works on the mixture of tension and compression, it is bending state, and they redistribute vertical load from their own load, from dead load, live load. It redistributes from itself on vertical elements like columns and walls. And the vertical load-bearing elements absorb all kinds of impacts and loads to the foundations and redistribute it on the ground. Also, we have randomly oriented in space elements like ramps, elements of variable cross section, and also other elements. So, and the next step for us is to analyze the subdivision of Malyan beam structural scheme on structural system. And we will analyze three main structural systems which are included in the Malyan beam structural scheme. Sorry, structural type. So the highest level of classification, structural type, then go structural system, and then structural scheme. And first of all, we have already considered structural type. Structural type. Now we will analyze structural system. All the structural systems which are included in the Malyan beam structural type. What is structural system? It's a static scheme of structure which is independent of its method of construction and material of the load-bearing element. So we have three main structural systems. It is frame structural. Here it's framed structural system, load bearing or with the load bearing walls, and composite or mixed. In sometimes it's called composite, sometimes it's called mixed. I will add it. Mixed because it is the mixture of frame inside. For this case, it's a frame inside and load bearing walls outside. And also we have additional type of classification called structural scheme. The structural scheme is the lowest level of classification. It's a variant of structural system in terms of composition and location in space of the main load-bearing structural elements like longitudinal, transverse, and mixed. When we're talking about the frame structural system, the defining feature in this case is the location of the frame beams. So we have for the frame system, we have with the longitudinal orientation of the beams with um, with the transverse location of the with the transverse location of the beams, crosswise located beams. So it's we have beams in both directions, and also we have a flat slab without beams type of structural scheme. By the way, when we are considering these structural schemes, we have to admit that the best case for us is a flat slab because it saves interior space and it gives an ability to make flat ceilings, and it also really it is really easy to make such structural elements at the construction sites. When we're talking about these solutions with the beams, with transverse beams, it is really hard to make at the construction site, but these solutions are widely used for in the case of the big spans, for example, in the seismic regions with the span more than 6.6 meters, we have to make beams into the slab, or when we have significant vertical loads, we have also to use transverse beams. Also, we have sub-classification of the load-bearing structural system. The structural schemes for the load-bearing systems are next, with the longitudinally arranged load-bearing walls, with transversely oriented walls, and also with crosswise arranged walls, load-bearing. So same idea. When we were talking about frames, it's longitudinal, transverse, and crosswise arranged beams. When we're talking about walls, same idea. Longitudinal, transversal, and crosswise located walls. And the final one, structural scheme for the mixed or composite structural system. We have also structural schemes. One of the variants, it is with the columns inside, walls outside. Another variant where we have walls inside, columns outside, and also we have two additional variants. We have columns on the bottom floors and the walls on the upper floors, and vice versa. Sometimes we have walls on the lower of the on the first and second floors, and we have columns on the upper floors. These makes us also possible to call this structural scheme also mixed or composite. And overall classification we can see at this table. So first level of classification, structural type. It consists of mullion beam, vaulted arch, and suspended. When we are considering structural systems for the mullion beam, we can see framed, load bearing, and mixed or composite. And also when we are analyzing structural schemes, we have for the framed four variants: longitudinal beams, transverse beams, crosswise arranged beams, and without beams or flat slabs. When we're talking about the structural schemes for the load-bearing structural system, we have longitudinal walls, transverse walls, and crosswise arranged walls. And when we're talking about mixed structural system, we have walls outside and columns inside, vice versa, and walls located below and columns above, and vice versa. So here is the classification that you had to understand during the first lecture of our course. Do you have any question, or everything is clear for you? So thank you. That's all for this lecture. So, and today we have also practice. Am I right? So next lesson we will start at 11:40, and it will be devoted to the practice. So that's all for the lecture. So see you in 20 minutes, and then we will consider our practice. Okay, thank you.